So today's topic name is STP. STP means spanning tree protocol. Yes. So by default, I want to let you know every switch has STP enabled by default. Every switch has by default STP. So by default, I want to show you one thing. By default, STP is enabled on every switch. Okay. So the question is, why? What is this protocol and why it is enabled? What is this protocol and why this is enabled? So you have to learn the concept. STP is a layer 2 protocol which is used to avoid the loop between switches redundant link. Redundant means duplicate links. This protocol helps you to avoid the loop between switches redundant link. For example, you have switch like this, because why we use switch? Why we use multiple switch? To extend the network. Why we use multiple switch? We have one switch of 24 ports. We have 35 people in my company. So if I want to add a new person with my LAN, so I have to connect switches with each other like this. Okay. But sometime for redundancy, we use concept like this. 2, 3 links, 4 links with each other. So at that time, what may be the problem? The problem may be if this is the person, this is the person. This person wants to send information to this, and it send packets to my switch. Switch send packet to another switch. Then this switch can broadcast the packet. So it can send through these ports and also send to this. If STP will not be there, then the packet will be arrived like this. So this is the process of looping. Looping means packet don't arrive to destination. It will flow from source to destination. So to solve this problem, we have to use the concept of spanning tree protocol. So I told you by default, spanning tree protocol is already configured over every switch. So you can check this. When you connect switch to switch with each other, you will check in Cisco Packet Tracer. I will show you the screen of Cisco Packet Tracer. If one switch is connected with another switch, and then multiple links are connected, for example, 1, 2, 3. So you can check. I will hide the port numbers from here. Option, preference, port label and device model name. Like yes. Now you can check. 3 links are connected from one switch to another switch, but you can check 3 links are green on this switch, but only 1 link is green on this switch. Another 2 are orange. If I connect one more link with this, by default, only 1 link is enabled. By default, only 1 link is working. So if my first link will break, for example, oh, sorry. Then you can check another link will be green. So this is an automatic process. How this process is done and why these ports are blocked. Only 1 port are like open. So the reason is by default, if all the ports are open, then loop can be occurred. So with the help of STP, it will elect something, it will do some programming, and one switch, all ports will be on, and another switch is only 1 port will be on. So the concept is how STP elect this process, how STP works on this, why these ports are blocked, why these ports are not blocked, why only this port, this switch is showing all the green links. And this is talk about only two switches. For example, I have another switch here. Okay, so here I'm using like this, and oh sorry, here I'm using like this and this. So you will check. Here is a chance of creating a loop. Understand the concept? So this link is orange. Like this is a blocked port. So what STP will do, if you are using STP, STP will block the port on a specific switch to avoid the loop. If you are using more switches like this, for example, you are using switch here and one more link connected to this, here link connected to this, then you can check. This port is blocked. This port is also blocked. Why two blocked ports are there? Because loop can be occurred there as well as loop can be occurred there also. And loop can be occurred there also. So that's why automatically it will close all the links. It will check the link. You can use the command to check that. This is theory topic, so we need to understand all the theoretical link. So the command to check spanning tree is show spanning tree. So in this, you can check this port is blocked. These ports are forward. And in this, you can check all links are forwards. So the question arises here, how this will elect all the process and what are the terms in spanning tree protocol. So get back to Alok question is why it is green in an other side. It is green in other side because we need to understand STP term first, then you will get to know about it. So I'm going to share the screen again and clear all drawing. Give me 1 second. Sorry. Okay. So STP is used to avoid the loop. So if you want to understand the process, you need to understand the STP terms. So we have 6 terms in STP. First of all, we need to understand this. 1, 2, 3, 4, 5, 6. Okay. First is root bridge. Second is non-root bridge. Actually, multi-port bridge is known as switch. So this is talking about switch. So root bridge is the switch only. Okay. Non-root bridge. BPDU, bridge protocol data unit. BPDU full form is bridge ID. Okay. Port cost. Path cost. Okay, so if you check your CCNA 200-301 book, you will understand all the concept. But first, I want to let you know these all terms because these are very important. So let me start with root bridge. What is a root bridge? So root bridge is the switch which has lowest or best bridge ID. Root bridge is the switch which have lowest or best bridge ID. Like I have 4 switch, I have to check what is the lowest bridge ID of all the 4 switch. Okay, so the lowest bridge ID switch is your root bridge. So to understand root bridge, you need to understand bridge ID first. And all the switches, all other switches that are not root bridge they are called non-root bridge. Like for example, in my class, I have 7 people are in my class. For example, I have 7 switch. So in 7 switch, if they all switches are connected with each other, one switch will act as a root bridge. The rest 6 switches act as a non-root bridge. Like for example, in my class, we have 1 monitor in my class. So 1 monitor, rest are non-monitor. So this is the concept there. So all other switches that are not root bridge, they are known as non-root bridge. Okay. Okay. BPDU. BPDU full form is Bridge Protocol Data Unit. Bridge Protocol Data Unit. Actually, the information passed from one switch to another switch is known as a frame. In OSA model, you have learned that thing. Okay. So Bridge Protocol Data Unit is the subsequent information that is passing between switch. I'm sending some data to Loic. I'm saying I'm sending BPDU to Loic. I'm sending something to Naprit. I'm saying that I'm sending BPDU to him. So BPDU means any information that I'm sending. And now what is a bridge ID? This is the most important thing in switch. Bridge ID is the combination of bridge priority plus base MAC address. Every switch has its own MAC address and bridge priority. So I will show you one thing first. Every switch has one fixed priority number 32768. That is fixed. I have 2 switch or I have 10 switch. Every switch has one unique number 32768. That is its bridge priority. You can check it on in the command of like this. Priority. Every switch has one same priority 32768. I will let you know in the last of class what is the priority, why we use this priority. But where is my theory? Yes, bridge priority is same for every switch, but MAC address is unique for everyone. For example, I have 4 switches, 1, 2, 3, 4. Okay, I have 1, 2, 3, 4. All the switches are connected with each other. Every switch has 3, 2, 7, 6, 8 priority. So everything has same priority, but MAC address is unique. So this is the MAC address A, this is the MAC address B, this is the MAC address C and D. Just give me 1 second. Okay, so bridge ID is the combination of bridge priority and base MAC address. It has MAC address A, it has B, it has C, it has D. So in root bridge, what we have learned, any switch which has lowest bridge ID is known as root bridge. Understand the concept? Any switch which has the lowest bridge ID. Now the election is not based on bridge priority. Why? Because it is same for every switch. Election is based on MAC address. So if I have 4 switch, for example, 4 switch, I'm going to delete, for example, this link. Okay. So I have to check the MAC address of every switch. Okay. Because I have already checked the priority. So I'm using command show spanning tree. So in bridge ID, you can check priority is 32768. So by default, all the ports are in VLAN number 1. So that's why every switch has priority 32769. And the MAC address of this switch is this. Copy. I'm going to paste here. So I'm checking show spanning tree here. This is the MAC address. I'm going to copy here. Show spanning tree. The MAC address of this switch is this. show spanning tree. This one. Okay. So now I have why I paste all the MAC address, because I just wanted to show you. Now it has 0090 starting number, 00D0. So 009 is like 00D is greater than 009, because 10 stands for A, 11 stands for B, 12 stands for C, and 13 stands for D. Understand? Hexadecimal values. So this is not our like part of root bridge, because this is greater value. Now in 009 and 006, which is greater? 009. So 006 is smaller. So it will not participate as a root bridge. Now 000B and 006, which is greater and which is less? 000 is less. So the MAC address of this switch is like lower than everyone. So when you check, this bridge is the root bridge. Understand the concept? The switch which has lower MAC address, that switch will become root bridge, and root bridges, all ports are green, designated port. I will show you designated. That I already told you, this is a theory topic, so you need to understand the concept. This is root bridge. This switch is a root bridge, and these three switches are known as non-root bridge. So they all switches exchange their BPDU with each other. Now the concept is, what is port cost? As you check in show spanning tree, there is something cost 19. Okay, why this is the cost? So I'm going to share my screen again with you. What is port cost? Now in spanning tree, port cost is by default fixed by IEEE company, Institute of Electrical and Electronics Engineering, because in switch there will be Ethernet port, there will be fast Ethernet port, there will be Giga Ethernet port, there will be 10 Giga Ethernet port. What is the meaning of Ethernet? Ethernet means 10 MB speed, fast Ethernet means 100 MB speed, Giga Ethernet means 1 GB speed. Okay, 10 Giga means 10,000 MB, 10 GB. Okay. So if your port is Ethernet, then the fixed cost is 100. If your port is fast Ethernet, then the fixed cost is 19. It is fixed by IEEE. By default, this is fixed. If your port is 10 Giga, normal Giga Ethernet, then cost is 4. If your port is 10 Giga, then it is 2. Okay. But in my switch, if I will check my switch, in my switch, I have fast Ethernet port. So the cost is 19. If I'm using Giga Ethernet port, I'm going to share the screen again of Cisco Packet Tracer. Here we have used fast Ethernet link. Okay, that's why cost is 19. If I'm changing this cable, here it is in Giga port. Here also I'm going to change into Giga port. Now in Giga port cost is 4. So when you will check show spanning tree again, then you can check cost is 4. And the last part is, what is path cost? So the path cost is total cost to reach root bridge. Total cost to reach root bridge. Path cost is that cost. Okay. So these are the STP terms. So now you understand that what is a root bridge actually. Okay. But you need to understand also that why only this switch has a blocked port, why this switch not has a blocked port, this switch not has a blocked port. So I'm going to change again to fast Ethernet. Okay. Why only this switch has a block port? Why blocking is not there or not there?
Because it's a higher.
This is higher. Yes, this is higher. But this time it is blocked because it has a maximum MAC address. But for example, I have connection like this. Now you need to understand all the concept like this. Now there are many blocked port, block port there, block port there. So what is the real process used in this? So for that, now you, after spanning tree terms, you need to learn about STP ports role. STP port role. So by default, we have 3 port role: designated, logged port, and root port. Designated and root port are already forwarding port. You can say designated and root are forwarding port. Forwarding port means it can send the information, it can receive the information. And what is your blocked port? Blocked port would not forward frames. Like blocked port can only receive. So that is blocked port. So rule is all non-root bridge. But first I have to let you know one thing. Root bridges, all port are designated port, always forwarding. So root bridge can never be blocked port. Okay, root bridge is always with designated ports. Now, what is a root port? Root port is the best port with the best cost to reach root bridge. So root port is the port that is always made on non-root bridges. Okay, non-root bridge. Get back to the design. This is the root bridge. So the port of root bridge is designated and designated. Understand? So this is a non-root bridge. Every non-root bridge has a root port. So root port is the best port with the best cost to reach root bridge. So we know that we are using fast Ethernet. The cost is 19. Okay. So now this is my first switch, non-root bridge. It has 2 ways to reach root bridge. Either it can go via this path or it can go via this path. Okay. If it go to root bridge via this path, the cost is 19. If it is go via another path, then the cost is 19 plus 19 plus 19. So this will be your root port because this is the best port to reach root bridge. Same as here, it is the root port. But why this port will be block and this port will be root bridge? Root port. The cost is same on the both sides. 1919, 1919. So the election is based on this. So this is the root port. Why? Because the cost is same. Now it will check the MAC address of these switches. So this is 0090, this is 0060. So 006 is lesser than 009. So that's why this is the root port. On this side, root will be blocked. Oh, sorry, port will be blocked. This is the criteria of blocking the port in the switch. One more thing you need to do in your theory, because it is a great port. So now you understand what is root port. Root port is on non-root bridge. Where is non-root bridge? This is. Okay. So blocked port, that is not able to forward the frames. So that's why it can receive the information but not send. So loop will not be there. Now you need to understand one more theoretical part in this. STP states. We have 5 states: disabled, blocked, listening, learning, learning and forwarding. disable, blocking, listening, learning, and forwarding. Okay, so STP total time to take. STP convergence time is 50 seconds total. And in this, listening will take 15 seconds, learning will take 15 seconds, 2 seconds is the hello timer, plus total 18 seconds it will take to up. So total, if you are working on real switches, it will take total 50 seconds to complete all the process. You want to check, then just go on to the switch. Wait, I'm going to add ports again. Wait. So I'm going to add, you can check. Click. Immediately I have to put the command show spanning tree. You can check your state is listening. Okay. After some time, you can check this state will be in learning state. Like after 15 seconds, it will be in LRN mode. Yes, you can check. Learning. So after 15 seconds, it will go into forwarding or in blocking state. Same as here. Show spanning tree. Root port, because I don't have any port here. You can check listening. Now that port will be blocked. Why? Because the election will be up and this port will be the root port. Understand everyone? This is the theory part of my STP. Now, get back to the point. We have one point missed here in theory part. What is the use of bridge priority? Remember that thing? Because bridge ID is the combination of 32768 plus MAC address. Now, by default, all the election is based on MAC address. So what is the meaning of priority? So the meaning of bridge priority is if you want to manually change the root bridge, if you want to change manually the root bridge, then what you have to do? You can manually change bridge priority. You can manually change bridge priority. For example, you don't want to make this root bridge. You want to make this switch as a root bridge. So there is a practical command only this. Spanning tree, VLAN 1, question mark. We have two commands only, priority and root. So priority, like you are not able to give priority like this. Okay, this is wrong. You can give priority from these values because priority must be increments in of 4095. Like it can be 0, 4095 plus 4095, 8192, 12,288, 16,000, 20,000. So every switch has this priority 32768. If I'm going to change the priority like 28,672, now show spanning tree, you can check this bridge is the root now because the priority is lesser of this switch and all port will be green after some time. This is the value of priority. So only one practical will be there in this topic, spanning tree VLAN 1 priority. And one thing you have seen with the command spanning tree VLAN 1 question mark. So either you can change the priority or you can use the root command. So root has two commands, primary and secondary. You can put the command primary here and you can put the command spanning tree VLAN 1 root secondary on another switch. So the meaning of this is primary will become root bridge, and if primary switch will be down, then this switch will become spanning tree root bridge. This is the meaning of commands. So we have only two practical commands, spanning tree VLAN 1 priority and spanning tree VLAN 1 root primary and secondary. So this is the topic of your spanning tree protocol, which is used to avoid the loop between switches redundant link. In this topic, we have learned states, we have learned port roles, we have learned terms. So if you feel any doubt in this topic, you can message to me. Until then, thank you so much. In my next video, we are going to use the important concept that name is ether channel. Okay, so thank you.